Alright, for numbers 1 and 2, you're writing a cosine function. So I highlighted a 1 period of cosine, and notice the amplitude goes, the function goes from 5 to -5, so the amplitude is 5. Let's see. The period is pi radians, and how you could tell is you could look at the sine curve and see, how long it takes to complete the cycle, or you can go from this point to this point, that's half of a period, and it took pi over 2 units. So when you double that, it's pi. So either way that you look at it, it's pi. So that means that b is 2 when you do this. 2 pi over b equals pi, you get b equals 2. Phase shift, it's pi over 4 to the right. Vertical shift or vertical translation, none. So the function would be y equals 5 cosine 2x minus pi over 4. And then you could also write the 2 inside the parentheses, inside the argument. So it would be y equals 5 cosine 2x minus pi over 2 when you distribute the 2. So either one of these is fine. Alright, so for number 2, I've highlighted the piece of the function of the graph that represents a cosine curve, like a 1 period beginning to end. The amplitude, well, for the amplitude, notice how it's 3 here and then -1 here. So that total distance is 4 units, so you cut it in half, so that gives you an amplitude of 2. The period is 2 pi, so that means that b is 1. Phase shift, it has none. Vertical shift, well, it had to go up 1 unit right here. Okay, so that way it's like 2 above the line and 2 below the line for the amplitude. So vertical shift, it's 1 up. So the equation would be y equals 2 cosine x and then plus 1. The plus 1 is not in parentheses with the x, it's a vertical translation. Okay, so for 3 now we're switching over to sine. Number 3 and 4, we're switching over to sine graphs or sine functions. I highlighted the sine function that I'm going to focus on as my starting function for the equation. The amplitude, if you count the tick marks, the maximum is at 5, the minimum is at 1. So from the dotted line, it's 2 units for the amplitude. 2 tick marks above and 2 below. The period, you can think of it in 2 ways. One, this would be like half a period from here to here, half a period. And it took 3 pi, so that means that 1 full period is 6 pi. Or do what I did here, where you extend the curve, all the way to its beginning, and knowing that if this is 3/2, then this is going to be -3/2, where it touches a dotted line. Okay, so you can count all of this distance, and it's 6 pi. So either way, again, period is 6 pi, and you do 2 pi over b is 6 pi. So then b is 1/3. So from that, b is 1/3. Phase shift, it moved to the left 3 pi over 2. So 3 pi over 2 to the left. Vertical, the dotted line is on the 3rd tick mark above the x-axis, so it's 3. And so the function is going to be y equals, and there's no reflection, so a is positive. Y equals 2 sine 1/3 x. Now it's to the left, so we put plus 3 pi over 2 plus 3. So that's one form. You could also distribute the 1/3, and you get y equals 2 sine parentheses 1/3 x. When you distribute the 1/3 with the 3 pi over 2, you get pi over 2 plus 3. Okay, so for number 4, I am going to have a negative a because the sine graph is upside down, right? It's reflected over the x-axis. So the amplitude is 1/2 because that's how much, if you look at this here, this is negative 1/2 and this is positive 1/2. So it's 1/2, but it's going to have a reflection over the x-axis. The period is 2 pi over 5, which means that b equals, so you set up 2 pi over b equals 2 pi over 5. So b is 5. Okay? Phase shift, none. Vertical shift, none. And so the function is going to be y equals negative 1/2 sine, so I didn't put 5 there, 5x. And that's it. Okay, so for number 5, the amplitude, the a value is 10. Now the negative in front of it tells you there's going to be a reflection over the x-axis. The period is 2 pi over 1/6. So when you simplify that, you get 12 pi. There is no phase shift and there is no vertical translation or shift. For number 6, it has an amplitude of 2. That's the a value. Again, because it's a negative 2, there is a reflection over the x-axis. The period is 2 pi over 2/3, because that's the b value, 2/3. So when you simplify that, you get 3 pi. Phase shift, none. Vertical shift, 5 units up. Number 7, you have amplitude of 3, no reflection. Period is 2 pi over 6, which would be pi over 3. Phase shift, it goes, you set this equal to 0 and you solve for x. So like 6x plus pi equals 0. Subtract pi, divide by 6. So it goes pi over 6 to the left. You could put negative pi over 6 if you like, but I always like to write out the actual direction, the word. Vertical shift, this one has none. Amplitude, the a value is 4 with a reflection. The period is 2 pi over 2/3. Okay, so again this is 3 pi. Phase shift, you set up the argument equal to 0, so then you have 2/3 x equals pi over 3 times 3 halves. 3 halves, so you get pi over 2 to the right. Vertical shift, none. For numbers 9 through 12, we have to write an equation. For 9, it's a sine equation, a sine function. The amplitude is 1/2, so you can write it f of x is 1/2 sine. Now you have to calculate b. Use the period to find b. And so here's the work in green. And you see the pi's cancel, so you have 6x, and a vertical shift of -4. So you could put it -4 like that. Or you could put f of x equals -4 plus 1/2 sine 6x. Either one is fine. For number 10, the period is 4 pi. So it's going to be 2 pi over b equals 4 pi. So then b equals 2 pi over 4 pi. Pi is, and then you reduce it to 1/2. So then f of x equals 7 sine 1/2. Now this one has a phase shift, right, of negative pi over 3. So that means that we're going to put x minus a negative pi over 3 like that. and no vertical translation, so we just leave that alone. There's nothing else to add. So now I'm going to distribute the 1/2. So you get f of x equals 7 sine 1/2 x plus pi over 6, because you distribute the 1/2. For 11, it's a cosine function, and the period is 2 pi. So then b is 1. You know that, right? Because that's 2 pi is like the normal period, the normal cycle. So we have f of x equals, amplitude is 1, so it's going to be just cosine x minus 5 pi over 6. Vertical shift is 3 plus 3. And that's it for that one. And then for 12, we have period is pi, so it's 2 pi over b equals pi. So b equals 2 pi over pi. Cross multiply, and you get 2. And so you have f of x equals, now the vertical shift is negative 1/2. So if you want, you could put that in the front right away if you'd like. And then amplitude is 3 cosine 2 for b, x minus a negative pi. Okay, so we distribute the 2, so we get, I'll just put equal, negative 1.5 plus 3 cosine 2x plus 2 pi. Okay, and there's the equation. Okay, so for the back side of the worksheet, you're writing equations. So 1 through 8 are all sine equations. So I went ahead and I highlighted one period of sine for the 6 that are on the screen right now. And then if there was vertical translation, I also showed the dotted line, right? So basically what I did is I took the altitude, the highest and the lowest point, and found the middle, and that's where you draw the dotted line. So for number 1, you have a vertical translation of 2. The amplitude here is 1. That's how high that is. And the period is 2 pi. Okay, so with that, we say y equals, amplitude is 1, and there's no reflection, so it's sine. Period is 2 pi, so it's a regular sine period, so it's just x. And then it went up 2 units, so plus 2. And that's it for that one. For number 2, the period is, let's see, 2 pi, right? Because I'm starting at pi over 2 and ending at 2.5 pi. Or you could think of it like this. If I look from here to here, that would be 1.5. 1.5 plus a half pi, that's 2 pi. So the period is 2 pi. The amplitude is 1. There is no vertical translation, but there is phase shift of pi over 2 to the right. So you would write y equals sine x. It went to the right, so you put minus pi over 2. Okay, for number 3, the period is pi. So 2 pi over b equals pi. So b equals 2. The amplitude is 1, and there is no phase shift or no vertical translation, so we just write y equals sine 2x. For number 4, there is no horizontal translation or phase shift. There is no vertical translation. The amplitude is 3, and the period is just a regular 2 pi cycle, right? So you're going to put y equals 3 sine x. For number 5, there is a reflection because it's upside down of what we usually see as a regular sine function, the parent function. The period is 2 pi. The amplitude is 2 units. And there is no phase shift, and again, no vertical translation. So we would write y, whoops, let me change the color. Y equals negative 2 sine x.